Okay, 5:31. This means I think we can start for today. Hello to everybody. I'd like to welcome you all to today's webinar about flexible reel-to-reel technology. My name is Daniel Görike, and I've been working at Lumitronics since over 6 years now, and I was specialized on projects and customers with reel-to-reel technology. So I'm very familiar with the topics that we will discuss today. So are my two colleagues who I have with me here today from North America. We have Stéphane Sendon and Nicolas Pourin here with me today, who will also take a part in the presentation. A few organizational topics in advance. I will start a presentation about the reel-to-reel technology very soon. During the whole meeting, you will be able to ask questions via the Teams chat. You will see on top of your screen, most likely, depending on which version you have of Teams, but in the middle on the screen on top, you can see a Q&A section where you will be able to text questions. And after the webinar ended or the presentation, we will go into discussion with you and answer your questions that you placed in the chat during the presentation. Yes. So feel free to ask, and we will be happy to get back to you after the meeting. You will also receive the video of the webinar and the presentation after the meeting if you contact us, and you will be able to have meetings via Teams with me and or my colleagues from North America. So yeah, then I hope you are all very interested in the topic, and I will start with the presentation now. I'd like to give you a quick overview of what you can expect today. So I already did a part introduction of the speakers that are here today. I will also give you a quick introduction about the company Lumitronics and where we come from. Then we will talk about roll-to-roll or reel-to-reel production, about the advantages of reel-to-reel and flexible modules in general. Then we will go into the production and post-processing in detail, so you get an overview of what we're actually doing with the process. Then we will go into material and manufacturing specifications. We will have a capacity example, what it means to produce reel-to-reel. And in the end, we will have more values and post-processing available. So I'd like to start with the introduction of the company Lumitronics. It was founded in 2005 by our CEO, Christian Hoffmann, and our head of sales and authorized signatory, Paul Sparenborg. We have currently roughly 50 employees, and we had a turnover of roughly 9 million euros last year. We are certified by quality management, by occupational safety, and by environmental management. Founding in 2005 means that we see ourselves as an LED specialist from day one. So when the technology LED got popular, we immediately started the business with it. It started with buying components from Asia and selling them in Europe, but our two founders noticed very quickly that there is a big market and demand for more detailed and more professionalized variants of LED technology. So in 2008 and 2009, we developed our own, or we founded our own soft and hardware development. And nowadays we have a team of roughly 15 people who will do hard and software development with you as our customers to get exactly the products that you need in the end. In the year 2010, we built up our first assembly machine for rigid LED modules. And in the year 2020, we also got a second production line, which is the reel-to-reel production, which we will be talking about today. And during these nearly 20 years of experience in the LED market, we developed a very unique partner network, and which I'd like to get a bit into detail about the partners. So from LED side, we are working with all the important brands on the market, such as Nichia, Lumileds, Osram, Seoul Semiconductor, and Cree, but also with Bulb as an UV specialist. We have close partnerships with optics manufacturers such as Lidl, Carclo, Gachon, or Ari or Ingemann, and further project partners such as Kasambi for controlling and ERP for power supplies. This was the quick introduction about Lumitronics and the partner network. Now I would like to hand over to my colleague Nicolas to explain you a little bit more detailed what real-to-real actually means.
Okay, thank you, Daniel. So diving in these webinar topics, here is how the reel-to-reel equipment looks like. It's a fully automated line with, from the LED and the connector component, reels that we are putting at the beginning. We are going to end up with flexible LED board reels. So this reel-to-reel process allows for automated and continuous production, leading to a very good efficiency and good higher output of the product itself. So speaking about this reel-to-reel production mechanism, the advantage of this is to specifically over the traditional method, we have a very good cost effectiveness and efficiency and reliability product mechanism. The reel-to-reel allows us for high volume automated production, reducing labor cost and assembly expenses. It's also enable process control over material usage, minimizing waste, and further lowering manufacturing costs. Furthermore, reel-to-reel eliminates the need of manual soldering in a traditional way, which can be a weak point in the traditional LED strip production, leading to a more reliable and more durable product. The reel length, as you can see, is 50 meters, and this is made in Germany with the quality of made in Germany. So the advantage of the reel-to-reel product itself, it's a continuous substrate, like we said, 50 meters, and there is no weak point on the LED tape, leading to dramatically reduced chance of failure compared to traditional method. There is multiple of automated checkpoints in the line through the entire production process, and the reel-to-reel can be cut to fit. So that's a big advantage compared to traditional LED board or other traditional method. It can bend or it can be shaped to any complex surface, making them ideal for application where precise curve or specific length are needed. Also, if you are thinking about a number of product SKU, it can be replacing several different rigid PCB board size, and in terms of space and storage, it's very compact and very low weight. So it's taking less storage space compared to a lot of boxes with different LED board. There is another very interesting point about the mounting, because we are putting as an option adhesive tape on the back of the PCB. It can replace the traditional screw mounting, and this is enabled to save a lot of labor cost and time of manufacturing. So again, this is how this production line looks like. And if you understood, it's a continuous process. So this is why it's very long, 21 meters or 69 feet. And this is how it's going to look like from the roll off of the PCB to the roll up of the finished LED flexible board at the end of the process. We are going to go more in detail about this process step by step. So this is the step number 1, okay? And on this step, we are just getting the roll off of this, we call it a drum, but it's a FPCB, flexible PCB, that is in a drum. And the maximum weight that this production process can support is 150 kilogram. Now that is the step number 2, and this is this process enable label printing for the full quality tracking of the product. So based on the inkjet printing system, we can do any type of barcode, batch number, customer specific requirement printed on demand on the PCB itself. And after that, we have the solder paste. So this is a fully automated solder paste printing system, and the width of the solder paste can be up to 610 millimeter. This is going to optimize cycle time in a few seconds, because if we are running 610 at the same time, you are going to optimize your cycle time in production. After the solder paste, like in a regular SMT machine equipment, you have the pick and place. This pick and place is very specific high-speed equipment for the LED, for the connector or specific IC, and it can go up to 50 to 500 components per hour. After the pick and place, you have the LED, so you need to go in a reflow oven. And in that case, in our production line, we have an infrared heating element. Same way that there is a temperature measurement by zone, and you can control separate heating element. It's very efficient, very compact compared to multi-zone traditional reflow oven. On this step, there is after the AOI and testing that can be also integrated in the production line. So in that case, we can test the lighting up using specific contact adapter on the board to automatically process a testing of the LED board. On the last or almost the last step, there is the cutting mechanism, because you need to separate the rails together. So this X and Y cutting, programmable cutting system is enabling directly to cut and to have a free-form cutting possible on the lane of the continuous process. And this is the final step. So when all the lanes are separate with the cutting system, we just need to roll up the LED with the assembly of the LED and the flexible strip in a reel. So really that's the end of the process. We are going from LED component to LED populated assembly reels. So because you understood that all those operations are not taking exactly the same time and the production doesn't stop, it's a continuous flow, we need multiple buffer in the line in order to adjust the speed and be able to support the manufacturing process. Like we said at the beginning, on the mounting option, there is more and more people that wants to easy laminated adhesive tape on the back of the PCB in order to get it more simple usage of the flexible strip. And in that case, this is done as a post-processing method on each reel. So each reel is going to this fully automated system in order to laminate on the back the adhesive tape that can be up to 45 millimeter. And we can do any type of adhesive tape, but we are using many often such name as 3M as a brand of the adhesive tape. Now I'm going to switch to my colleague Stefan, which is going to really speak about material specification on how we are using this specific product in this production line.
You're on mute, Stefan.
Sorry. Thank you, Nicola, for the summary of the production line, and also thanks for everybody for being with us today. Just going to go quickly over some aspect that we consider when we analyze your project. As we mentioned, this is a reel-to-reel process that is made for flexible circuit. We currently process either single or dual layer circuit. We tend to favor single layer, obviously, because it's more cost effective. For single layer, we typically use a substrate, a base material of polyamide, often written as PI, of 25 micron or 50 micron thickness. We added some of the North American measurement for those would be in North America. The material we use is copper, either 35, 70 micron, in some cases 105 microns. So that's would be 1 ounce, 2 ounce, or 3 ounce in North America. And for as a protective layer, solder stop, we use coverlay. We try to use coverlay as much as possible, and in some cases solder mask. So that would be for one layer. And for two layers, sometimes the design won't necessarily fit in one layer, or sometimes you need added current carrying capacity. Therefore, then we fall back on two layer. It's more expensive, but sometimes there's no way to avoid it. It's very similar to single layer. Aside from the fact you'll see there is under the main polyamide, we have another copper layer and an extra protection layer coverlay. So, but it's in same as one layer, 25 or 50 micron polyamide, very often 25 micron when we go double layer, and we use twice 35 micron and twice 70 micron. I think usually it's 70 micron with some deposit on it, but we do not have the option of using 105 microns at this point in time. So that would be for two layers. As seen on the picture and as explained by Nicola earlier, we use a very long, continuous, flexible PC printed circuit. Typically 50 meters, could be 100 meter long. The width is, we focus on two sizes, 250 millimeters and 500 millimeters. We often call this big roll a drum internally. So if you hear that, that's what we're talking about. It that also dictate to a certain extent the quantity we can do at per production batch, and we'll get back to that later. Quick note that we need some space on each side of that flexible PC. So we need about 10 millimeter on each side. So when we're talking 250 millimeter wide flexible PC, there's 230 that remains that we can use. And same thing for 500, there's 480 millimeter that remains. And these margin, if we can call it like that, are meant for fiducial, technical information, and also transportation along the line. So in single layer, we have 250 and 500 millimeter FPCB, therefore usable on one layer. We have 230 and 480. As for two layers, we have to rely on the narrower material, so we only have 230 millimeter usable width. The production image is basically the repeated step we have along the line. It's the repeated image that we have over and over 50 meters. So if you would have something that is longer than that cannot be split, we would need to organize around it and discuss with you, but gives you an idea of the image we can process at one time. And the full 610 millimeter will depend on your circuit length. Very often we have much smaller than that, so we'll fit as many as we can within an image to optimize the process. So something that a quick explanation on how much length we can do over a batch of production, which is also usually our MOQ. You take the usable width of the flexible PCB and you divide it by the strip width. So obviously the larger the strip, the less we do across the width of the flexible PCB. And then you multiply that by the real length. So for example, if we have a 10 millimeter strip on a 2-layer material, as we mentioned before, a 2-layer material would be automatically 250 millimeter drums, removing 10 millimeter on each side, leaves us with 230 millimeter. If we divide it by 10 for the strip, it means that we have 23 strips done at the very same time over 50 meters, and that would give you 1,150 meters. And we apologize for those used with comma or dot to separate the 1,000, but this is truly 1,150 meters, which would be the equivalent of almost 4,000 feet for those who are more used to feet in North America. If we summarize a bit the thing we review when we analyze your project, again, the length that you want, usually 50 meters, sometimes 100. Obviously, we can customize to shorter if you need to. We review how much flexible strip we can place on the main material. And again, that's usually 230 millimeter or 480 millimeters on 1 layer and 230 millimeters on 2 layers. We have to review the image that we can use for your product. So we may have some adjustment to do. And as for calculation, other calculation that taking like a 1-layer design, in that case, like I mentioned, 500 millimeters for the width minus 10 on each side leaves us with 480 millimeters. If we divide it by 10, that gives us 48 strips done at the very same time over 50 meters, and that gives 2,400 meters or almost 8,000 feet of calculation. So overall, that means that our capacity, for example, doing a 10 millimeter wide strip would be 7,200 meters per day, or roughly 24,000 feet per day. And over a year, that would be pretty much 1,800 kilometers per year, or 1.1 miles, 1,000 miles per year of flexible circuit. So we can produce quite a lot of this material for you. And I believe I will hand back the discussion to Daniel.
Yes. Thank you very much, gentlemen, for your parts. I will get back to some added values that we can do after the actual reel-to-reel process. So you can see what possibilities we have except for just the assembly of components. The first thing that we can obviously do for Flex is prepare customized lengths. So if you don't want to have a full reel of flexible material, but you need pre-cut strips into 1 meter, 2 meter, or 5 meter, whatever you need, we can just prepare that for you and deliver it according to your needs. We can also attach wires or full cable harnesses on the FPC, depending if you need it or if you want us to do it. We can do full assembly of strips into profiles that we either buy for you or that you send us to work with, The same applies for housings or heat sinks. We can optimize products and light output by application of lenses, which we would typically glue on flexible material. And we can also, during our production, or even when going into the FPC specification, prepare perforation, so you can take out single pieces of material, in some cases, of your application in the end. Then we have next process, which is called Loom Protect, which we invented here in Germany, in Hechingen, in our facility, which allows us to laminate flexible PCBs over a large area. This results in reliable protection against environmental influences, such as chemicals, liquids, or even mechanical influences, for example, vandalism. I'd like to dig a bit deeper into detail, but not too deep. So we already had some webinars, especially about the Loom Protect technology. So if you need more detailed information, please get back to us after the meeting and or after the webinar, and we will send you additional information and presentation about this topic, or get back to us in a Teams meeting, of course. So Loom Protect is a lamination for flexible strips, and it results in a few advantages of the LED module in the end. We have an IP67 protection of the module. We have very high resistance against various chemicals, and therefore the modules are also very easy to clean. So if you had a permanent marker on the strip, you could just remove it by alcohol cleaning possibilities. We have a very high material transparency, at minimum over 96%. Due to the isolation layers, we have a very high dielectric strength. Compared to normal potting, we have hardly any color shift. So usually for cold white, it will be a little bit larger than for warm white, but we definitely have a lot of improvements compared to normal potting. We can laminate very large areas, which means our machine is capable of basically laminating a whole drum width of 500 millimeters that we have. And depending on the application, we can also do several meters in length. This needs to be discussed in detail. We have different ways of processing the materials. So the surface can either be very smooth or can have structured elements. This will not really affect the light output of the strips, but will be more like a haptic, another feeling to the materials. We can have different designs possible. So in the picture, you can see that the strips have a black edge on each side. This is also a material which you will find on the back of the strip. This is just a textile which is made for optical reasons. So you will have the possibility to choose, do I want a textile on the back? Which color should it be to match it to your application in the end? We have several contacting and sealing options, such as solder connections, shrink tubes, connectors, and so on. To dive quickly into the process itself, so on the right side, you can see how Loom Protect is basically set up. We have different layers of plastics, which will be wrapped around the material, and then under high heat and pressure, it will be melted and then cooled, so it sticks together in the end. So a loom protection layer is always around the complete or the whole FPC. This also means that once the strip is laminated and you cut it, you will break this protection layer. So what we highly recommend is to tell us which length of lamination you need, so we can prepare it for you and send it to you already in the correct length, because cutting will lose the protection of the strip, which is not ideal, of course. Yes, the material composition can be adjusted depending on the intended use. This just means if you have any special requirements, we can always discuss about it. But the materials we're using are, for example, already used in solar systems. So they are for outside applications and UV resistant, for example. So this is our context. You can read it in the presentation once we send it to you. This was the official part of the webinar. So I will close the presentation for now. And thank you for your for sticking by. And we will hop into the Q&A section and see if there's some questions. What does the SMD testing process include was the first question. The testing basically is only a functional test in the line. So we will check, does the LED light up, and does it light up in the exact location where it should be, sorry. So it is not a measurement of color temperature or lumen output, but it is more like a functional test. If you have any specific requirements on the testing, please also get back to us after the webinar and we can get a bit into detail, because of course we can also have testing after the reel-to-reel process itself to have high voltage resistance tests or something. We also do that already. What is the maximum power per meter in this process? Do you refer on the testing, I think? I have to admit that I don't have an exact number, but if you could please, Golan, get back to us after the webinar with an exact description of what your request is, then I will gladly get back to you with some more detailed information. I will actually already write that down. Okay, so far there is no other questions. I'd like to... the question relates to reel-to-reel. Okay, thank you. So maximum power per meter for reel-to-reel products. I think I can hand over this question to Stefan, since you already talked about copper layers. I think it is a related topic, so maybe you can explain a little bit about this.
So I'll be honest with you, Golan, I don't have an exact number, but I can give you an example of a product we're doing right now. The product outputs around 1500 lumens, and the strip is about 10 millimeter by 1 foot, which is roughly 30 centimeters. So, I mean, we can back calculate that. I could do that, here, but I don't know if that gives you an idea, but usually we don't really have problems with power when it comes to reel-to-reel. Obviously, if we're talking about a big array of high power LED, that might be a different topic, but it really depends on your application. So again, unfortunately, I don't have an exact number that we tested, but hopefully the example I gave you gives you a rough idea of what you're able to expect, on the surface I mentioned.
Okay, thank you, Stefan. I think the maximum power is also just depending on copper thickness and also on the layout of the strip. So if you have any high power applications, send us an information so we can dig in detail about it. Okay, this is the only 2 questions so far, so I would give everyone another minute to place a question in the Q&A section. So I'd just take a few seconds to see if there's anything else. Okay. If there's any questions later on, please make sure to contact us. Oh, there is one. Okay. I'm interested in making 34 watts per meter in 12 millimeters. Golan, if it would be okay for you, I think this would be a good opportunity to set up a quick discussion and afterwards and to discuss your application in detail, because I think it would be a bit too detailed for the whole group right now. So please make sure to contact us after, and we are happy to help you in this matter. Okay, so then thank you everyone for attending. I hope we could give you some good insight about the reel-to-reel process.
Daniel?
Yeah.
There's one more question in the Q&A section by Mohammed.
Oh, sorry. How is the repairability of the reel-to-reel products compared to rigid strips? Nico, can I hand this question over to you?
So reel-to-reel product in terms of reliability and repairability, I mean, if this is an LED question, yeah, you can repair the same way that you have a regular strip, but because it's a continuous process and there is no soldering or anything, there will be no issue in terms of the quality or the fact that you can have a solder joint that can break. So it's just an LED that can be broken or damaged, and then you can replace the LED same way. So you can just go and put a new LED by doing like a manual soldering process. So if I can just comment, the repairability of this reel-to-reel product is better than in any rigid strip. Yes.
Okay. Thank you, Nico. Okay, Mohammed gives thumbs up. This means this answered your question. Very nice. Okay, then thank you very much for attending. If you have any more questions afterwards, please let us know. If you're interested in the presentation and in the video of the webinar, just let us know and we will send it to you. And yeah, for the European people, I have a good evening, and for the American people, have a good start to the day. And see you in the next webinar. Bye.
Thank you.